Okay. Uh, this is a continuation of lecture on Friday, and I have to redo this video. It's because I lost the there was a corrupt file on the video, and I have to re-record to complete this example. Okay. So Friday lecture. Right. So the next thing that we are going to find is we are going to find the shearing stress due to By. Okay, so we analyze and we realize that we have Vy was Vy, and Vy is coming at 25 times 10 to the power 3 Newton. And the stresses we are interested on is for element A. So we apply thin wall analysis, and because it's an I-beam, it's classified as wide flange. So for this case, you have a Q only. Okay, so you will construct the shear flow. So you have terminal here. All these dots are your terminal. You draw your shear flow. Okay. So the area of interest now is this area now. Okay, I will stop here and highlight in yellow. This is the area of interest. Okay, so the formula that we're going to apply is shear. So the plane intersect the z-axis. The shear flow is going to x, okay, and at point A, so this will be equal to By over Ixx Qx divided by T. So the information that we know, that we are aware, is Vy is a constant. We are also aware that we know that our Ixx is equal to 40.8. And we also know the thickness is also equal to 11.8. Because this is the thickness. Okay. And the thickness is also equal to TF, which is equal to 11.8. So we're going to find Qx, which is equal to the width multiplied by depth multiplied by y bar. So the axis that the first moment of area of takeoff is xx direction. So when that's the case, parallel to the xx is the width, perpendicular this direction is our depth. Okay, so for this case, our width is equal to 75, because the distance to A 75, the depth is 11.8, the y bar D is 205 divided by 2 minus by 11.8 divided by 2. Okay, so this will give us 205 divided by 2 minus 11.8 divided by 2 times 11.8 times 75 is equal to 35.491. times 10 to the power 3 millimeter cube, or 85.491 times 10 to the power minus 6 meter cube. Okay, so now we know everything. We can calculate our shear. Okay, and I'm going to use the space over here. We can calculate our shear Zx at point A is equal to 25 times 10 to the power 3 multiplied by 85.491 times 10 to the power minus 6 divided by 40.8, 10 to the power minus 6, and thickness is 11.8 times 10 to the power minus 3. So this will give us 191 power minus 6 divided by 40.8 power minus 6 divided by 11.8 power minus 3, 4.439. Okay, 4.439 times 10 to the power 6 Pascal. Okay, I want you to take note of the shear stress direction is going to left to right. Okay, when we calculate the shear stress earlier over here, it's also for element A. Okay, is going from right to left. Okay, so now we are going to construct the element A. Okay, we're going to draw element A. Okay, so we are going to draw element A, put the related stresses. Okay, so I'm going to sketch element A. 2, 4, 6. Okay. So this is our element A. And then we have our transformation. This is our X. This is our Y. This is our Z. And from our analysis, we realize that stress Z is tensile, is equal to 29.852 times 10 to the power 6 Pascal. Then the shear stress, we have to be careful, okay? So due to Vx, right? Due to Vx, I'll write down here, okay? So due to Vx, we have a shearing stress. So this one is due to Vx. We have shearing stress 6.047, okay? So we have a shear stress going this way, 6.047, okay? Then due to Vy is coming in the opposite direction and is going at 4.439. Okay, so the shear stress in this direction. Okay, so this is our shear intersecting plane is Z. The right direction is X. Will be equal to 6.047 minus by 4.439. Okay, so 6.047, 4.439 is 16.08 times, no, not 16, 1.608 times 10 to the power 6 Pascal. Okay, so then you have a coupled shear over here. So this arrow is your shear intersecting plane is X. The direction of the stress is in Z direction. Okay. So for term test 2, I will test you until constructing of the element. So for your homework, just construct the element. Okay. So important to know how to draw the elements with the associated stresses. Okay. So term test, I'll test you into here. Now, why the question is why I pick this as positive, this as negative? Because by observing the value, okay, I know that the shear stress is going in this direction. So I pick that as positive. Okay. So that's the only reason. Okay, that's all, and have a great weekend. Thank you.